today we are starting off our class with reviewing a little bit of the logarithmic to exponential forms that we've been doing previously and solving these logarithmic equations. And so the first thing that I would like to do is review a little bit. And for this review, I would like you to work on 3 different problems. And for these 3 different problems, I'm not actually going to give you any numbers, but you should find numbers or expressions from them by switching them into exponential form. So if I give you log base a of 0, log base a of a, and log base a of 1 divided by a, I would like you to solve for our implicit x, which each of these is equal to. And I will give you a few moments to work on that, and I will pause while you do. Now that we've taken a little bit of time, row 4, person 5. Katie, could you give us, for the first one, how did you rewrite this in exponential form? All right, so now we need some power will get us to 0. What power will get us to 0? Will any power get us to 0? No. So x does not exist. So I'm just going to put DNE for does not exist. Katie, would you like to call on somebody? Row 5, person 1. So could you let us know, what did you get for this next one? A to the x equals a, so x equals 1, because a is the same thing as a to the power of 1, indeed. Okay, would you like to call on somebody? Row 2, person 1. Hello. X equals -1. What is the exponential form first? Okay, so from a to the x equals 1 over a, you've got that x is equal to -1. Awesome. From here, if you look not at this slide, but at this yellow slide here, kind of jumping, I know. It's going to be okay. If we look here, they want us to graph the log base a of x is equal to y. I don't know about you, but I don't know what a logarithm graph looks like off the top of my head. So if I don't know what the graph looks like, but I need to graph it, what should I do first? I heard it.
XY chart.
Thanks. An XY chart would be a great place to start. And for an XY chart, what if I put a as x? I would end up with log base a of a is equal to x. Didn't we just solve that? What did we get? Was it 1? Awesome. What about an x of 1 over a? We got -1 from our warm-up. Now, this one's a little bit different. We haven't done this one yet. What if I wanted an x of 1? If I wanted an x of 1, that would be the same thing as saying log base a of 1 is equal to x. If you take a moment and write that into exponential form, how could we solve for x? I'll give you a moment to do so. And once you have found x, if you could flip your iPad towards me, I will pause while we do this. We have found that our y value is equal to 0 when our x value is equal to 1. So if I wanted to plot this on my graph, I don't really have numbers, but if I'm looking at 1 divided by a and 1, which one is larger? If you have 1 divided by a, it's probably a fraction, and then you have 1. I believe 1 would be larger than a fraction. So my first tick mark here, I'm going to put 1 over a. My second tick mark, I'm going to put 1. And then my third tick mark, I'm going to put a, because I believe that is the order from smallest to greatest for those values. And those are my x values, and I want my y values. My y values will either be 1, -1, or 0. So here's 1, here's -1. And if you take a few seconds to plot this, you will find I have a point here, a point here, and a point here. And what did we find before when we set x equal to 0? What did y equal? In our warm-up, we said, what if x is 0? Then what does y equal? So you two, look back at what we just did. It does not exist. Exactly. So that was this first one up here that we did. It doesn't exist at that point. So if it doesn't exist, what is true about x equals 0? It is indeed an asymptote. Nothing can exist at x equals 0. It's not part of our domain. So based off of this, we have this asymptote here. We have these 3 points. So since we have this asymptote, that probably means our graph is going to look like this. Now this was just for some base called a. What if I decided that I wanted a to equal 2? If I wanted a to equal 2, what would I have to change in my graph? Would the graph itself look different? Or, right here, when I said I just want a base of 2, I just said, okay, instead of a, I'm going to make a equal 2, right? If a equals 2, and I have an a down here, what does this a equal? 2, again. And over here, I have another a, and I'm just going to have that equal 2. So I have the same exact graph as I did before. All I did was, wherever I saw an a, I just put a 2. Because all I did here was I just replaced my base of a with a base of 2. If I wanted to do the same thing over here, what if, instead of 2, I used e? Remember the e that we talked about last Friday? That e is some number that's about like 2.71 and then a lot of decimal places after that. So it is a number. But if we want log base e, is our graph going to change? Is it going to change its shape? It's the same graph, right? You still have this asymptote here. You still have a -1 and a +1 for your y values. You still have these 3 tick marks that we called 1 over a, 1, and a. But instead of using a, what are we going to use now? Just whatever we have here. E. So instead of a, I'm going to replace all of my a's with e's. And it ends up being the same shape for our graph. Except this needs to be moved over. There we go. What I would like you to do now, on this graph here, don't plot this yet. Just plot, if I wanted log base 4 of x is equal to y, how could you plot that on this graph here? I'll give you a few moments to work on this. If you are stuck, ask the people around you to help. Now that we've had some time, I see a lot of people are using XY tables. So if we start this off with an XY table, what is one point that you put on your XY table. Row 5, person 2, okay, 1, 0 exists on our XY table. Would you like to call in somebody for the next? Okay. Row 3, person 6 would come back up to Greta. 4, 1 is on our XY table. And is there someone else who has another point that they would like to volunteer that they put on their XY table? Volunteer. Otherwise, I'll just call on whomever I choose. Yeah. 1/4, -1. It's another point that you can have on your XY table. You can have any point you want to choose. So that works. So that means that if we have 1/4, these are going to go by 1s here. And these will go by 1s here. If I have a fourth is kind of like right here-ish. So if I have a fourth, -1, that's going to be here. If I have 4, 1, that's going to be here. And if I have 1, 0, that's going to end up there. And do we have an asymptote? Where's our asymptote at? X = 0, indeed. So that means that our graph looks like this. Did it change its shape at all from where we had it before? So if you look here, and then we look down here, has the shape changed? It hasn't. The only thing that has changed is our values of a fourth and 4 instead of a half and 2, or 1/a and a. Right? Okay, so we have graphed log base 4 of x, except the original problem for 6 asks for this x plus 3. If we think back to transformations, I know it was a very long time ago. If we have an x, or if we have a plus 3 with the x, does that mean that we're moving up and down or left and right? So we have left and right, and we do not trust what's inside the parentheses. So we're going to move left or right? Left. So if we're moving left, all we have to do is we have to take our graph, and we have to move it 3 to the left. So I'm going to move 1, 2, 3 to the left. So here, we have moved it 3 to the left. Somebody last hour asked, well, what about the asymptote? You can't cross an asymptote, right? What happens to our asymptote in this situation? Our asymptote here will move over. So now instead of being at x = 0, we have our asymptote at x = -3. So it's over there. Okay. See? I would like you to try graphing this one. I will give you a few moments. It's a little bit different. There's also something in here that we didn't really talk about that came from up here. When we had log base e, there's actually a special name for if you have a base of e because they use it so much. And that special name is right here. And it looks like an L and then an N and then an X. And if you say ln of x, I will cry a lot. It's called the natural log of x. And most people say ln of x, but it is the natural log, which is how we remember that it is part of our log family. So if you just have a log with base e, that just means it's a natural log. So if we look at this example here, they give us this ln, which is a natural log. So if we have a natural log, how could we rewrite this in terms of log? What would go in as our base? So with that in mind, try figuring this one out. Figure out what the base is, and then graph this. however you can. I will pause while you do so. A lot of people, I see a lot of people working hard on this one. This one is kind of hard, so let's go through it. So if you have something where you just don't know what to do with this x minus 3, I would always simplify it first. If we simplified this and we just said, don't worry about the x minus 3, this would just be y equals the natural log of x. If we just are trying to graph the natural log of x, haven't we already done that? If we look up at a previous slide over here, wasn't this side over here just the natural log of x? So you could take this graph here and just copy it onto this new one that we're doing right now. The only changes we would have are you have your 3 tick marks here. One of them is 1 divided by e. The other one is 1, and the last one is e. And for our y values, we still have 1 and negative 1. And this would give us our 3 dots, as well as our horizontal asymptote here. So we would end up with this graph if we were just looking for y equals natural log of x. Right now, we have natural log of x, but don't we need x minus 3? So if we need x minus 3, on your iPad right now, write what that would mean. How would I have to transform my function to get it to be x minus 3 instead of just x? Once you have written it, share it with the people around you and see if your answer matches their answer. Okay, where are we moving it? Since everybody now knows, since they talked to somebody, row 4, person 6 would be Ryan. We would indeed move it right 3. So from here, you would just move it right 3. And I don't really know where 3 is in terms of ease. I don't know about you. So I'm going to kind of take a simpler way out, and I'm just going to plus 3 to each of these. And if I have 1 plus 3, that's a 4. And remember that you also have to move your asymptote. If your asymptote was at x equals 0, and you moved everything over to the right 3, that means that you also have to move your asymptote over 3. So if I could select all of this, I would move it all over 3. So it won't let me move more than one thing at a time. I will redraw instead of doing this one. I will redraw so that this right here, that's 3. And here's our graph here. And this right here is 4. This right here is 1 over e plus 3. And this over here is e plus 3 with your accompanying y values, if you so choose. Okay, we're going to take a little break from that and look at something else. And what I would like to look at is, let's look at 2 different logarithm problems. So the first one I would like to look at is log base 2 of 4. And the second one I would like to look at is log base 2 of 8. This side of the class could you solve the one on the left? And this side of the class, could you solve the one on the right? We want to just solve out that logarithm. So if you need to, you can use your calculator. Just put it into your calculator, see what you get. So we'll pause while I give you a few moments. We're solving these, and so whenever we're solving these, there's just some implicit x that it's equal to. So basically, we're just solving for x. So if I look at row 5, person 6 would be, go back to Quentin. Could you tell us what you got for this x value here? 2? Okay. And did you solve it by putting it in exponential form first? So what was the exponential form you found? So we have 2 to the x equals 4, and 2 to the second power equals 4. So x is equal to 2. Awesome. Quentin, would you like to call in somebody from this side of the room to give us the other one? I can roll it if you want me to. Yeah. Okay. I have to roll. Okay. How about row 1, person 1? Did you get what our x value here was? And then did you put it into exponential form to solve that? How, what was the exponential form? 2 to the x equals 8. Awesome. If we look at these, what if this is, this is something that's kind of a trick that you can use that will help you solve these a little bit faster if you're kind of good at exponents and you don't really like using logs. So up here, we had log base 2 of 4. Did you notice that this 2 here and this 4 here, 2 is a factor of 4? So if I wrote this as log base 2, and I said, okay, I know that 2 can go into 4. So I wrote this as a 2. 2 to what power will get me to 4? Just 2. What about this one over here? 5 log base 2, and I want to write this with a base of 2 in my argument. What power would I need to get to 8? But isn't this 2 here and this 3 here just the same thing as this answer that we got? In fact, if I said, let's go log base 10 of 100. If I looked at this and I said, I have a 10 here, and I can rewrite this in terms of 10. And I can rewrite this as log base 10 of 10 to some power. If I know what that power is, that power right there will be your answer. That's just your x value. So if you can get it into this form, you can find your x value without even having to rewrite it in exponential form. Now, what if I have log base 2 of 32? If I have log base 2 of 32, there are 2 ways that we can look at this. If I'm just looking at a base of 2, 2 to what power will get me to 32? Does anybody know? What do you think, Emil? 2 to the 5th power will get us to 32. Show of hands, who actually knew that off the top of their head? I don't. So this log base 2, where we can find a base of 2 and it goes to the 5th power, if you can do this, great, you found x. If you can't do this though, what are some factors of 32? 4 and 8 are factors of 32. What if I just rewrote this as log base 2 of 4 times 8? If I did this, I know that 4 is just 2 to the power of 2, and 8 is to the power, to get 8, I just need 2 to the power of 3. If I have 2 exponents like I do here, and they are multiplied by the same base, what can I do with those exponents? So doesn't this just become log base 2 of 2 to the 5th? And all of a sudden, I have the same thing that I had up here. So I can just say 5 is my x. The reason why we can say that this power here is what we're solving for is because if you have a log to some base, like here, and you have the same base in your argument to some power, these will just cancel out, and all you'll be left with is just the power. So if I have log base 2 of 2, what does x equal to? Well, if you have 2, a base of 2, and you have another base of 2 here, and you cross them out, this is just 2 to the power of 1. So your answer is just 1. Wait, hold on a sec. So we found that if you get here log base 2 of 4 times 8, you'll end up with 5 as your answer. If we go back up here, and we just looked at the log base 2 of 4, and we looked at log base 2 of 8, we got 2 for this answer, and 3 for this answer. And if we add them together, what do we get? 5? Wait, wasn't that our answer down here? When we just multiplied them together? In every single instance, if I said log base 2 of 4 times 8, that gets me 5, right? That's also equal to log base 2 of 4 plus log base 2 of 8. And that's not something that just happens because I chose 4 and 8. That's something that will happen every single time. So if I have just any kind of base, b, and I multiply together 2 numbers, let's say x and y, that's the same thing as if I just said log base b of just x plus log base b of just y. This is one of the logarithmic properties that we will be learning. We will go over the other 2 tomorrow, but what I would like you to do is, if you look at the homework, this is still kind of from the same homework section that we had last time, I believe. I would like you to do this whole page. There's 3 questions on this page. So I believe this is like 2 after the one that you did last week, or over the weekend. It's just these 3 problems I would like you to do for homework tonight. And since that is the end of all that we are learning today, I will end our recording here.